Myself Dr. T. Sudhakar, Department of Biomedical Engineering, School of Bio and Chemical Engineering. Today I am going to give a lecture about analytical instrumentation regarding the chromatographic techniques. Chromatography technique is widely employed in the laboratories and research, and it has many applications in the field of biomedical and biotechnology. First of all, you must know what is chromatography. Chromatography is a physical method for the separation of mixture of components by using two phases. One phase will be the stationary phase, other phase will be the mobile phase. Based upon these two phases, the components are separated from a mixture of sample. And even we can call this technique as a purification technique, which is a basic purification technique employed in the life sciences for the purification of drug, protein, enzyme, etc. Chromatographic techniques are classified into two, gas and liquid chromatography. We see about the classification of liquid chromatography. The first one is going to be the paper chromatography, second one thin layer chromatography, third ion exchange chromatography, fourth column chromatography, fifth gel permeation chromatography. All these are the examples for liquid chromatography. If you go for the gas chromatography, the number one is the liquid chromatography, which we will call it as GLC. The second one is going to be the HPLC. Now, first, if you are going to see about the two chromatographic techniques today, first one is going to be about the paper chromatography. Paper chromatography, the separation is based upon paper adsorption or paper partition. First, you must know what is paper adsorption. In the case of paper chromatography, the paper adsorption, the silica gel is used as a stationary phase and the organic solvents is used as a mobile phase. If you go for paper partition, the moisture or the water which is present in the cellulose paper, it acts as a stationary phase, and organic solvent, it acts as a mobile phase. Coming to about the principle of the paper chromatography, the sample you are going to separate it. The principle is based upon the paper partition rather than paper adsorption. Okay. So, since you are going to follow the principle of paper partition, so which will be the stationary phase and which will be the mobile phase? So, you are going to use the Whatman filter paper as your stationary phase. So, why we call it as a stationary phase? Because the cellulose fiber which is present here, the water or the moisture which is present in the cellulose fiber, it acts as a stationary phase, and organic solvent, it acts as a mobile phase. So, this follows the principle of paper partition, not the paper adsorption. Next, after the principle, you must know what all the methods you are going to employ for separating your sample using paper chromatography. The first one is the selection of the solvent. The solvent which you are going to use it for the separation in the case of paper chromatography, mostly you are going to use N-butanol, glacial acetic acid and water in the ratio of 4:1:5. And as I said, this is the mobile phase, and the stationary phase is going to be the Whatman filter paper. And this Whatman filter paper, it has been graded into three. Whatman filter paper number 1, 2, 3. And these variation is depending upon the thickness of the Whatman filter paper, flow rate and the purity. This is about the stationary phase and mobile phase. As I said in the introduction part itself, in the case of the chromatography technique, you are going to separate the sample by two phases. One is the stationary phase, other one is the mobile phase. So, here the paper, Whatman filter paper is the stationary phase and the organic solvent is the mobile phase. Now, the two phases are ready for separating the sample. So, now we will go for the methodology. You are going to take a Whatman filter paper 1, you have to see to that you are not supposed to touch your finger in your paper, because it may have an error in separating there will be no proper separation of the components. So, you have to use a forceps and you have to cut in the form of your rectangle, and you are going to spot the sample. While spotting the sample, you have to see to that it has to be not spotted at the edge of the paper, it has to be spotted 2 centimeter top of your Whatman filter paper. After loading the sample, you are supposed to take the filter paper and you are going to place it over a glass beaker which is having the solvent. That solvent is going to act as your mobile phase. So, the mobile phase, whichever you are going to use it, it is selected based upon the sample you are going to separate. For enzymes it may be different, for protein it may be different, or for any drug it can be different. Most commonly employed mobile phase is going to be the N-butanol glacial acetic acid in water in the ratio of 4:1:5, which has to be kept in a glass jar. Since it is an organic solvent, it has to be closed with a lid to prevent the evaporation of the solvent. Next, you have to take the paper gently and you have to place it over the glass jar which is closed with the lid, and the organic solvents which is present in the jar and the sample which has been loaded in the water and filter paper, now you are subjecting it to chromatographic technique. The solvent, it makes the sample to drag to separate from one end to the other end, and you have to see carefully when it's reached the other end of the paper, you have to stop the development of the chromatogram. Once the development is over, you have to take the water and filter paper, you have to take it and you have to keep it for drying. Now you have to see whether the separation has been completed or not. So what you have to do is, after drying the paper, you have to go it for detecting it. Mostly whatever sample you are going to use it can be a colored one. If it is going to be a colored one, you can visualize it through your naked eye. If it is going to be a colorless sample, you have to do it for detecting by two methods. One is going to be the direct method, other one is going to be the indirect method. First we will see about the direct method. For example, I am going to separate the amino acid by using a paper chromatography technique. The direct method for visualizing the separated amino acid is going to be by spraying a ninhydrin. This ninhydrin, it interacts with the amino acid and it shows a purple color spot, and you can see where our sample has been separated out. If it is going to be a indirect method, you have to take a small beaker. That beaker you are going to add a iodine, and you are going to keep a water and filter paper 1 for detecting the separation of the component. You are going to close the beaker is going to close with the lid. This iodine fumes, it interacts with the sample and it produces a brown color compound. This is the indirect method. After detecting where our sample has been separated, the next step you have to see what is the qualitative and quantitative analysis. Usually mostly you used to go for qualitative analysis, that is retardation factor, that is called RF, the distance traveled by the solute divided by distance traveled by the solvent, which is going to be usually less than 1. The separated sample, after doing the RF calculation, you can compare with the standard and find out what is our compound we are separated out. If we are going for quantitative analysis can be done by two methods. One is going to be the direct method by using a densitometer, and second one is going to be the indirect method. But mostly we will be using the densitometer to find out the density of the spot. Among qualitative and quantitative analysis, mostly which we will be following in our laboratory is the qualitative analysis, that is the retardation factor. That is, as I said, the distance traveled by the solute divided by distance traveled by the solvent, which is going to be always less than the 1. For example, I am going to separate my compound, any pigment from any soil. It is an unknown sample. That sample, after calculating the RF, I can compare in a database what is the RF value for the particular compound, and I can conclude that this is my sample. So this applications of this paper chromatography, it is widely used. It can be employed in a basic lab itself. It is widely used to see the separation of the amino acids, separation of your drug, and mostly used in your forensic studies, and it has many applications in the field of your microbiology, biochemistry, and biotechnology. So this is the first chromatographic technique. The second chromatographic technique is going to be the thin layer chromatography. But we see the paper chromatography, the separation of the components is based upon the paper partition. But in the case of your thin layer chromatography, the separation is going to be about paper adsorption. Why it's so? Because here you are going to use the stationary phase is going to be the silica gel, which acts as a stationary phase and it's a absorbent. And the mobile phase, as usual, you are going to use your solvent, that is the organic solvent. Now we will see about, this is the introduction part. Now we will see about the principle of this chromatographic technique. As I said, you are going to use the separation of the TLCs based upon adsorption. The silica gel is going to be used as an adsorbent, and the sample, by using the silica gel, it is separated by using an organic solvent, and the organic solvent, by the capillary action against the gravitational force, the components are separated. How? Since we are using silica gel as a stationary phase, the components which are going to separate it, if it has more affinity towards the stationary phase, it moves slow, it elutes out of the column very slow, that is from your TLC plate. If it has the less affinity towards the stationary phase, it moves very fast. So the components in the case of TLC, it is separated based upon the affinity towards the stationary phase, what you are going to use it. So this is the principle of the TLC, that is thin layer chromatography. Then we are going to go for your activation. So now this is the principle. Now you must know how we are going to do this TLC, which can be generally done in our laboratory itself. You are going to use the silica gel as your stationary phase, which is absorbent. Nowadays the silica gel, this is the TLC plate, is available ready-made. But before, what you have to do it, you can take a normal glass plate. To that you are going to add your silica gel. How? The silica gel, which is going to be in the powder form, it is going to be mixed with your water, the ratio of 1:2. To that you are going to add a calcium sulfate, which acts as a binder. This binder makes the silica gel to fix to the glass plate. So with help of a TLC spreader, you are going to roll the TLC reservoir towards the plate, glass plate, where the silica gel is going to be formed, which acts as a stationary phase. Earlier they had to follow this step, but nowadays the silica gel strip itself available ready-madely, so no need of activation or preparation of your TLC plate. So now once your TLC plate is ready, that is which acts as a stationary phase, now we have to make ready of your mobile phase. As I said, these two phases are required for separation of the components. So the mobile phase, whichever you are going to use it, it is going depends upon the sample which you are going to separate it. It can be a ethyl acetate or chloroform or hexane, whatever it may be. This solvent, it depends upon what type of sample you are going to separate it. Based upon this, your organic solvents are selected. Now your stationary phase and mobile both are ready. You have to separate the components. As I said in the earlier chromatographic technique, you have to use your glass beaker, the glass beaker which is filled with the organic solvent, which you are going to use it based upon your components to be separated. You are going to you are going to take the TLC plate which is spotted with the sample. You are going to load it over the, you are going to, after loading, you are going to keep it inside the glass jar. You are going to close it. Now the sample, by your capillary action against the gravitational force, it gets separated out. So once it is separated out, if it is going to be a colored compound, it can be seen through our eye. It is going to be a colorless. As usual, you have to go for detecting it, one by direct method, other one is the indirect method. Then after detection of the compound, you have to go for qualitative and quantitative analysis. As I said, the qualitative method is widely employed because it is a retardation factor which gives the distance traveled by the solute divided by distance traveled by a solvent, which is going to be always less than 1, which can be compared with your standard TLC chart. Like this, the components which are going to be separated is identified and detected and further employed for your other further continuation of research work. The application mostly you can use for the separation of your components for finding out any drug or any pigment, whatever it may be. You can see whether your component has a single compound or it is going to be a multiple compounds. Now apart from this, your other chromatography techniques, that is your column chromatography, ionization chromatography, gel permission chromatography, which comes under the example of a liquid chromatography, and other one is the gas chromatography, which I am going to say about the gas liquid chromatography and HPLC. I will continue in the forthcoming session. Okay, you might have got basic idea about your chromatography technique. Thank you.